In this project, we'll be doing 2 hypothesis tests and 1 confidence interval. And we'll be comparing one specific region to the national market for housing sales. And these are the 3 questions we're going to be answering. The first 2 we're going to take care of with those hypothesis tests. And then the third one is a confidence interval. In the introduction section, talk about those 3 questions you'll be answering and how you're going to answer them using hypothesis test for the first 2 and building a confidence interval for the third one. Then we are going to be taking a random sample. The directions say that your sample size should be 100 rows from one of the specific regions. And make sure you explain how you got your sample and how you ensured it was random. I recommend using the random function here in Excel. You get a random number for each row, drag that down for all the cells, sort by smallest to largest, and then pick the first 100 rows. That is a great way to get a random sample. If you use a different method, just please explain how you made sure it was a random sample. So here I'm going to go to, I have all my data selected. I'm going to sort by that column. G has those random numbers, smallest to largest. And now I'm just going to go up to the top and select the first 100 rows, and that is my random sample. And briefly describe your sample. What region was it taken from? What states make up that region? You don't need to do anything with the years or months, but what region and what states are in that region for your sample. So my region was South Atlantic, and then I could go through and list which states make up the South Atlantic region. And then for your 2 hypothesis questions, talk about what those questions are, what population parameter you're trying to answer questions about. And we're going to cover that in more detail later on in this video as we work through each of those hypothesis tests. So as I talk more about those in that section, it'll help you if you have any questions about how to answer this part. And our first hypothesis test that we'll be doing is a one-tailed test, and it tells you right here that you'll be doing a greater than test to the right of, to the right-hand tail. And so our alternative hypothesis should have a greater than sign, and we'll be doing a right-hand tail test. So let's look at what that first question is. Are housing prices in your regional market higher than the national market average? You need to scroll down to the bottom, click on the national statistics and graphs, so that then you can see what the national average is for listing price. And so just find out what it is right here from clicking on that. And that is a value we're assuming to be true. We know what the national mean is for listing price, and we're going to compare our region to that value. And so we need to hypothesize about our region. We know the national mean, it was listed there. We don't know the mean for our region. So what we're going to do is use our sample, our 100 rows of data, to test our hypothesis here. Our null is going to be that we're exactly the same as the national. And then our alternative will be what we're trying to prove and see if there's evidence that our regional mean is actually greater than what that national mean is. Now, if our null hypothesis is actually true and our regional mean is equal to that value of the national mean, we know by the central limit theorem that if we take samples from our regional mean, the means of those samples will follow a normal distribution. So most of the means from those samples will be somewhere close to this middle value from our distribution, what our null hypothesis is for what the regional mean is. There'll be very few samples that have a mean way far out in one of the tails. So we have a sample now of size 100. We're going to look at what the mean of that sample is. If it's somewhere close, if the probability, the p-value of getting that sample is above our alpha, we will fail to reject our null hypothesis. There's no evidence that's really proved anything. Either way, there's just not enough evidence to reject it. There's no reason to reject it. Now, if the mean of our sample comes out way far out here in the tail, And the p-value, the probability of getting a sample like we did, or one even further in the tail, is very small. The probability of our sample mean is less than our alpha. Now that's statistically significant evidence that our null hypothesis should be rejected. Because there's really just two options here. Either we got a very rare, very unusual sample that produced a mean way out here in the distribution, or this value was wrong, our null hypothesis was wrong. And the reason we got a sample mean way far up off here to the right is because the population mean for our region is actually somewhere over here to the right. And if it was over here, then it'd be likely that we get sample means near where the real population mean is for our region. And so that's what we assume is happening if we get a sample mean way far over here. It's a very low p-value. We assume our null is wrong, and we're going to accept the alternative as true, that our regional mean is greater than that known value for the national mean. So let's work through and solve this hypothesis test. Our population parameter, it's the listing price of homes in our region. Write out your null and your alternative hypothesis like we just discussed. And significance level, I suggest using 0.05. That's very standard to use for hypothesis tests. But if you pick a different one, that's fine. Just justify why you chose a different significance level. So go through your sample data you have here, create at least one histogram, give the summary statistics listed out here, what I'm looking for: mean, median, standard deviation. And then talk a little bit about your data, any information that's given from that histogram, from those summary statistics. Does the data in your region look skewed? Is it symmetric, bell-shaped? What's going on there with your data? And then let's talk about how we know it is okay to go ahead and run a hypothesis test. So coming back to 5.2 in the Zybooks, we're going to be doing a t-distribution test because we do not know the population standard deviation for our region. And that's almost always the case. If you knew the population standard deviation, you'd probably know the population mean already. So we wouldn't be hypothesizing about what it was. We would just know what it is. So it's almost always the case that we use the t-distribution for our test here because we do not know the population standard deviation. So there's three things here. Our data, we're assuming it's collected randomly. Independence, getting data from one county doesn't affect what the data is from another county. So we have independent observations here. And then for the third criteria, we either need to know that our population for our region is normal, or we just need to take a sufficiently large sample size, something bigger than 30, which we have here with our sample size of 100. One other thing I would like you to do is when you look at your histogram or if you draw a scatter plot, see if any extreme outliers are present, because if you have gathered a sample that has a lot of outliers in it, it may be a very rare sample that produces a very rare sample mean that ends up being way far out in the tail of the distribution. And it could cause you to reject the null hypothesis by mistake because you had a sample with a lot of outliers and it was just one of those rare samples. Now, we're not going to do anything with that really in this project, but in a real life application, you would want to note that. Note that there were a lot of outliers in your sample, and you may want to circle back to that later and gather more data, another sample, to really confirm that your conclusions were correct to either reject or fail to reject the null hypothesis. So next, you want to calculate your t-test statistic. The formula is listed here. Find the p-value of that test statistic, and it tells you the formula to use in Excel. And then if the p-value is less than your significance level, we reject the null. If it's greater than the significance level, we fail to reject the null. So there is in the book written out in symbols. Remember, your degrees of freedom is one less than your sample size. So I'm going to calculate the t-test statistic here for my hypothesis test. I use the equals average to find my sample mean, standard deviation.s to find my sample standard deviation. And then here is my null hypothesis for what the population mean is for house listing price. So I take my sample mean and subtract that. That gives me the top number with my t-test statistic. So I'm just going to reference, or I'll just click on it there, that value minus my null hypothesis. And then to get the bottom value, I'm going to take my sample standard deviation and I divide by the square root of my sample size, which was 100. And I got my bottom number. So now to get the t-test, my t-test statistic here, I take that top number and divide it by the bottom number. And there we go. And it shouldn't be as money here. Let me just make that a general number. And I'm getting a pretty small test statistic value here, something kind of close to 0, indicating my sample is not very far away from the middle of the distribution. And we can kind of see that my sample mean isn't very far away from the middle of the distribution, what I'm assuming the population mean is. And let's just check that with our p-value here. What's the probability of getting a sample like this, or one even further to the right hand of the tail? t.dist.rt, because we're doing a right-hand tail test. And you want your test statistic there. One less than your sample size is your degrees of freedom. And that's what I get back for my p-value. That's going to be larger than my alpha, so I will fail to reject my null hypothesis, which in the context of this just means I have no support for that alternative, which said that my region had a higher listing price than the national average. There's no evidence to support that. So now for the two-tailed test, let's go back and review that second question. Is the square footage for homes in the region, so we're looking at square footage now, different? So not necessarily larger or smaller, but just different than the mean for the national market. And so anytime you're looking at just trying to find if something's different, that's a two-tailed test, because we want to know if is it larger or smaller, anything different. Look at those national statistics. The mean for square footage, I'm looking at, down here, 1944 is what the national market average is. Our null hypothesis set up pretty much the same way. We're just going to assume we have equality, and then we're going to look to see from our sample, looking at our sample mean, is there proof that our regional mean is not equal to the national mean? So this time we need to check not just one of the tails, we're going to kind of be checking both tails. Does our sample produce a mean that's somewhere far out into either one of those tails? And that is when we would reject the null hypothesis in favor of the alternative. So going back to the template, our population parameter now is the mean for square footage in our region, the region you're looking at. State your significance level and go through your sample data. And again, create at least one histogram, maybe do a scatter plot. Let me see the mean, standard deviations, all that information. Does the square footage appear to be symmetric, or is it skewed? Is there some pattern you're noticing with that? And then talk through those steps again about how we know we can run a hypothesis test using our sample of size 100 that we've gathered. Proceeding from there, we're going to find the test statistic just like we did with our one-tailed hypothesis test. We have a different function for finding the p-value when you're looking in both tails of the distribution, and then the interpretation is exactly the same. If your p-value, the probability of getting a sample like you did, is less than your significance level, that's when we reject the null hypothesis. So coming into Excel, I need to switch this from column L over to my square footage, which is in column N. And this is one of the things I love about Excel, is you can reuse a lot of what you did the first time around here just by switching to the correct data now. So I get the mean of my sample, the standard deviation of my sample. My null hypothesis is that the population mean for my region is equal to the national, or the mean of the national market here. Sample size is the same. And these should have all updated because I used cell reference, but let's just walk through that and make sure it's correct. And before I even do that, I wanted to look. My mean doesn't look like it's too far off from the null. It's kind of close. Let's see how the results turn out. Top of the formula, take the sample mean minus the null hypothesis. the bottom of the formula, the sample standard deviation divided by the square root of the sample size, and then your t-test statistic, divide that top number by the bottom number. And so, again, that should just be a general number. It's fairly close to 0, so my sample isn't really that uncommon. In the distribution of sample means, it seems to be not too far away from the center of that distribution, but let's really check that with the p-value here. This is the wrong one. That's just the right-tailed p-value. So I need to make sure, I'm going to leave that there. I'll tell you why in a second. But I'm doing a two-tailed. I forgot my period here. T dot dist dot 2t. And so with my test statistic, my degrees of freedom, one less than the sample size, I get, this is the probability of getting a test statistic like the one I did, or one even further into one of the two tails. And that p-value is larger than my alpha, so I will fail to reject the null hypothesis based off of this sample data I have. So again, there's no real conclusive anything statistically significant that I figured out here. I have no proof that my region has a higher square footage average than the national average. I said I left this here for a reason. Look what you get when you multiply that by 2. I'm going to multiply that by 2. And so now you can kind of see where the two-tailed calculation is coming from. You just double what the one-tailed calculation is for the probability. The last part of the template is called comparison of the test results, and we're going to see how a confidence interval and a hypothesis test are kind of like two sides of the same coin. The results are going to support one another. So on step 3 here, we're again looking at square footage, and we're looking for a 95% confidence interval. For our region, we're looking at the square footage, and we can compare that to the results we got from our hypothesis test. If we reject the null in the hypothesis test, then our confidence interval will not contain the null hypothesis. If we fail to reject the null, then our confidence interval will contain the null hypothesis. In the book, you can see the formula we're going to be using to find the margin of error and to build our confidence interval. And the information we need is our significance level. It has to be 0.05. That's what you use with the 95% confidence level. And then your sample standard deviation, and then your sample size. So the 3 pieces of information you have to enter into the formula. So I'm going to come over here and let's just see what we get. It's going to be confidence.t, again, t distribution because we don't know the population standard deviation. We have, for 95% confidence, that's 5% then for alpha, so it's 0.05. Your standard deviation, I'm just going to click on what I got here for the standard deviation of my sample, and my sample size was 100. So this gives me the margin of error. And so when building a confidence interval, it's always centered around the mean. You're going to get your lower bound, and you're going to get your upper bound, and we're going to be 95% confident that the population mean for our region, the square footage mean for our region, lies somewhere between the lower and upper bound. And our sample mean is going to be right smack dab in the very middle of our confidence interval. Every time the sample mean's in the middle, because you take the sample mean and you subtract the margin of error. That's how you get the lower bound. You take the sample mean and you add the margin of error. That's how you get the upper bound. And so we're 95% confident that the population mean in our region for square footage lies somewhere within that range of numbers. Now remember, I failed to reject my null hypothesis, and this confidence interval kind of supports that decision because this interval of numbers contains my null hypothesis is within that interval of numbers. So there's really no statistical evidence from both of these approaches causing me to reject this as a possible correct value for the population mean in my region. and then just wrap up your project with a little summarization. Refer back to those 3 questions. Summarize your answers to those 3 questions here. Discuss if you were surprised by any of the results, why or why not. If you think there's anything else that would be important to look into to kind of confirm your results, discuss all that here, and that will conclude your project. Let me know if anything is unclear. I'll be happy to help out more, and good luck.